Our National Transportation Policy Statement is something that I've been very much involved with. I'm Tom Larson, Federal Highway Administrator. And one of the themes of that policy is a very close and detailed look at technology, how it can help us to move America forward. One of the conflicts we have inevitably with our highway program is facing the utility relocation problem. We need to have better ways to deal with locating and avoiding conflicts with utilities. There's a new technology now, a subsurface engineering technology, that allows us to identify and really to mitigate this problem very early on. This tape is about that technology. I would commend it to you as a way to really help us in our overall initiative towards applying better technology to the national transportation scene, particularly to better highways.
We have a report of a utility break on the site of the new Memorial Highway overpass. Traffic is at a standstill in all the northbound.
It's a familiar scene. A construction crew strikes an underground utility, a facility not discovered during the design and planning stages. And although it was inventoried as construction began, the precise location of the utility was badly misjudged. Such an error can be costly. It can mean a long construction delay, redesign of the project, and unplanned relocation or repair of the utility. It can afflict the surrounding residential and commercial communities, restricting travel and making it difficult to do business. Insurance premiums might rise, and settlement of claims arising from the incident could add untold amounts in legal expense. In fact, the total cost from a single accident may run into the millions, and it may take years to resolve the claims. In the end, no one wins. Accidents involving underground utilities are becoming more and more complex, and the effects more and more serious, if not deadly. Fortunately, modern technology has supplied solutions that reduce this risk in a practice called subsurface utility engineering. This emerging new discipline is the result of a convergence of events, the development of appropriate technology, and the rapid proliferation of underground utilities, especially in urban areas. For engineering professionals, it represents a significant technological achievement. For public and private sector developers, it's an economic breakthrough.
Well, underground utilities have really proliferated, and now you have cable TV, you have electricity underground. It used to be on poles above ground, telephone lines are underneath, gas and everything is going underneath now, so we get rid of the so-called urban sprawl that's ugly and unsightly, trying to put it out of sight. And I'm delighted to learn that in the last few years, a new technology has developed to help identify these underground utilities so that engineers can know just where they are and hopefully avoid them.
Subsurface utility engineering is a multifaceted discipline. Some of the technology is related to the principles that help fortify America's highly sophisticated submarine fleet. Advanced sonic and electromagnetic technologies have application in what is known as the designating component of subsurface utility engineering. Designating is indicating by marking the existence and approximate horizontal location of subsurface facilities. Professionals using geophysical techniques such as electromagnetics and sonics designate utility lines and other subterranean structures without excavation. A relatively small crew can designate horizontal placement of utility lines over a large area in minimal time. This phase of the process can enable broad-scope engineering decisions to be made in the early conceptual stage of the project.
4 years ago, we started with the governor's mandate to move the construction program forward. With his initiative, the then governor's initiative, we were given the money to do the job, and we set as a goal to move projects 20% faster. So the subsurface work was a vital part of that, so that we could locate the utilities, miss the utilities, and move the projects faster. So if we can find the conflict points, design around them, then we can move a project much faster, and it has been a part of our program, a vital part of it.
Vital to the ability to move projects ahead faster is the ability to combine speed with accuracy. In addition to designating approximate horizontal positions, subsurface utility engineering can precisely locate utility lines. Locating is another important component of the new discipline. Designating technologies alone do not provide the high accuracy required at the production engineering and construction phases of the project. But by applying vacuum excavation technology, trained technicians can expose the underground facility through an opening no larger than 8 inches by 8 inches, so the process does not detrimentally intrude on surface activity. The vacuum excavation technique has another advantage. It is non-destructive to utility lines. At critical points along its path, selected as part of the prior designating process, technicians measure and record both the precise depth of the utility line and its horizontal position.
The benefit of this new technology and its application to the surveying business has greatly enhanced our productivity. It has also greatly enhanced the accuracy of our location work. Last but not least, it has reduced our liability for errors. From the surveyor's point of view, we make one trip to the site. We get all the data early on, and the designer has all supporting data needed to design the project.
No matter how well the subsurface utility information is collected, its usefulness in the design process depends on how well the data is recorded, transferred, and applied. So state-of-the-art data management techniques are used. Data mapping utilizes the advanced technique of computer-aided design and drafting, the CAD system. When the computer overlays the field data onto the designer's plans, an underground picture of the site begins to emerge. With this information, design engineers can develop one or more scenarios that take utility placements into consideration. They can recommend relocation of utilities, or that a new site be chosen because utility relocation will make the project costs too expensive. Design engineers can proceed confidently to finish designs. The result is a dramatic reduction in the overall time needed to take the project from drawing table to completion. There are dramatic economic benefits since the prospects for utility-related construction delays are reduced, as are chances for cost overruns and disruption of public services. The resulting savings in time and in damage loss prevention can run in the millions of dollars.
The particular project that we recently analyzed was in the city of Richmond, and it was a project that we dug 156 test holes. We found that more than half of those test holes were actual conflict with the utility facilities and eliminated all conflicts except for 14. On that job, we feel like we eliminated over $700,000 worth of utility conflicts, and the cost of excavating the test holes were less than $100,000. In Virginia, we really feel that the subsurface utility engineering program has been very valuable to us. We cannot imagine going back and doing a project without having the information that is provided under this program available to us in order to incorporate into the overall design of a highway construction project.
Perhaps most important is the impact of subsurface utility engineering on the question of liability. This new engineering discipline offers significantly improved risk management capability. The risks come in several forms: catastrophic risk, the potential loss of life and limb, and major property damage, which can result from improperly located utilities. Loss of service associated with damaged telephone, electric, gas, and other utilities. Project losses caused by delays, redesign costs, and other unexpected costs. And hazards associated with buried systems, which can be damaged during construction and which may pollute the environment. Subsurface utility engineering provides the ability to plan in advance to reduce these risks.
Now, this is our Beltway project number 26.
Consistent with the standards of the engineering profession, all aspects of subsurface utility engineering, from the early designating phase to the later and more accurate locating phase and beyond to utility relocation, are conducted under the direct responsible charge of a registered professional.
In the alignment of the interchange, to save the overall project $512,000.
As required by most states, subsurface utility engineering is a professional service. The work product is sealed, and as required on a state-by-state basis, the providers of subsurface utility engineering are selected based on proven qualifications. As with any other professional service, many states require coverage by professional liability insurance. As America continues to grow, as urban centers expand, as we build and modernize the nation's infrastructure to extend our highways and repair bridges, create mass transportation, and improve public services, the role of subsurface utility engineering will grow with us. It is a breakthrough whose time has come, a technology to help us build safely and efficiently toward the next century.